question, evaluate integral 0 to 2, integral 0 to root of 2x minus x square plus y square dx dy, changing into polar coordinates. Okay, now I am doing the solution. So solution, so it was given that 0 to 2 and 0 to 2x minus x square plus y square dx dy. Then observe the limits here. The first limits are as a functions of x here, then these limits are y limits and constants limits are x limits. So okay, and given limits, given limits, y is equal to 0 to y is equal to 2x minus x square. Then squaring on both sides, y square is equal to 2x minus x square. Then x square plus y square is equal to 2x. Then similarly, the x limits, x is equal to 0 to 2 here. Okay students, so now changing into polar coordinates, changing into polar coordinates. So of course we know the substitutions of polar coordinates. They are x is equal to r cos theta, y is equal to r sin theta, and dx dy is equal to r dr d theta. Okay students, so now by using these three substitutions you can change the given Cartesian form question into polar form. Then if you are changing as a polar form, we need r and theta limits here. Then how to find out the limits here? Then y is equal to 0 and x is equal to 0 was given here. Then using y is equal to 0 and x is equal to 0. So if y is 0, then r sin theta is 0. Then sin theta is 0, that implies theta is equal to 0. Okay, if x is equal to 0, then r cos theta is equal to 0. Then cos theta is equal to 0. Then theta is equal to pi by 2. So these two are the theta limits here. Then how to find out the r limits here? Then using x square plus y square is equal to 2x. So in general we know that x square plus y square is equal to r square is here, r square, and 2 into x is nothing but here x value is r cos theta. X value is r cos theta. One r will be cancelled and r is equal to 2 cos theta. Then 2 cos theta is the one limit. So here the lower limits are 0 here. Then the r lower limit, because the required region is in the first quadrant only, then r limits 0 to 2 cos theta, and theta limits 0 to pi by 2. Okay, and the given question, integrand term is as x square plus y square dx dy. Then you have to change that integrand term also by using the substitutions. So at first I am writing the limits. Integral r is equal to 0 to 2 cos theta and theta is equal to 0 to pi by 2. Yes, the given question is x square plus y square into dx dy was given in the question. Then x square plus y square is nothing but r square, and dx dy is r dr d theta. So at first doing integration with respect to r students, because r limits are in terms of theta here. Then integral theta is equal to 0 to pi by 2 r cubed, and integral r is equal to 0 to 2 cos theta. R cubed dr is the first integration, and second integration is with respect to theta here. You are doing with respect to r integration here. Then integral theta is equal to 0 to pi by 2. R cubed integration is r power 4 by 4, 0 to 2 cos theta and d theta. Yeah, integral theta is equal to 0 to pi by 2. 1 by 4 common. For r I am substituting 2 cos theta whole power 4 into d theta, because in the place of r only we are substituting the limit 2 cos theta. Then r power 4 is there, that means 2 cos theta whole power 4. Yeah, 1 by 4 into integral theta is equal to 0 to pi by 2. 2 power 4 cos power 4 theta and again d theta. Then 2 power 4 by 4 integral theta is equal to 0 to pi by 2 cos power 4 theta d theta. Then 2 power 4 is nothing but 16 here. 16 by 4 is 4. Then using the even formula, n minus 1 by n, that means 3 by 4, n minus 3 by n minus 2, it is 1 by 2, and again into pi by 2. Then 4 will be cancelled, and final answer of this question is 3 pi by 4. Okay students, the next question, evaluate the next question, evaluate integral 0 to infinity and integral 0 to infinity e power minus of x square plus y square dx dy using change of variables. Using change of variables. Okay, the same substitutions here for this question also we are using to change the polar form here. Yeah, the solution. So it was given that integral 0 to infinity e power minus of x square plus y square dx dy. So observe here in the question 4 limits are given as a 0 to infinity. Then we may take the values of first limits as a y or second limits as a y, because there is no variable limits here. Then y is equal to 0 to infinity and x is nothing but here 0 to infinity only. So then by changing polar coordinates, then by changing into polar coordinates, what are the substitutions students? X is equal to r cos theta, y is equal to r sin theta, and dx dy is equal to r dr d theta. Yeah. If you are doing all these substitution, the question will be becomes in terms of r and theta here. Then we need the r and theta limits here. So by using y is equal to 0 and again x is equal to 0, then y is nothing but here r sin theta is equal to 0, then theta is 0. By using x is equal to 0, r cos theta is equal to 0, then theta is nothing but 0 to pi by 2. These two are the limits of theta is equal to 0 to pi by 2. So of course now we need the limits of r here. Then using r limits here, that means at r is equal to 0. Okay students, but in the question it was given that y is equal to 0 to y is equal to infinity was given here. Okay, so by using y is equal to 0 we find out the limit of theta. Then by using y is equal to infinity here, then for r sin theta is equal to infinity. Okay, if r sin theta is nothing but infinity here, then r is also infinity here, because r becomes as infinity by sin, then r becomes as a infinity. Then you may use x is equal to infinity also. Then r is a infinity limit here, it is the upper limit, because in the question two lower limits are 0 here, then required region is in the first quadrant only. Then r limits are 0 to infinity, and theta limits are 0 to pi by 2. Okay, now doing the integration of the given question, changing the integrand term also as a polar form here. Yeah, okay, then integral r is equal to 0 to infinity and theta is equal to 0 to pi by 2 e power minus of x square plus y square is there in the given question. Then writing r square, and dx dy is there, then dx dy is r dr d theta. Okay, so at first I am doing integration with respect to r here, pi by 2, integration r is equal to 0 to infinity r e power minus r square and dr first integration, and next one is d theta. Then to do this integration we need substitution method here. Then that substitution is nothing but here r square is equal to, put r square is equal to t, differentiating with respect to t here, 2r dr is equal to dt. Then r dr is dt by 2. So when r is equal to 0, t is 0, and r is equal to infinity, t is also infinity here. So now using these substitutions, integral theta is equal to 0 to pi by 2, and integral now changing as a variable to r to t here, t is equal to 0 to infinity. So at first I am doing substitution for this function e power, okay, minus r square means t, and this r dr is nothing but here dt by 2 and into d theta. Yeah, 1 by 2 common, integral theta is equal to 0 to pi by 2, and integral t is equal to 0 to infinity e power minus t and into dt into d theta. So now integration with respect to t here, e power minus t integration 1 by 2 theta is equal to 0 to pi by 2 e power minus t by minus 1 0 to infinity d theta. Then this minus also, minus 1 by 2 theta is equal to 0 to pi by 2 e power minus infinity e power 0 students, upper limit minus lower limit. Yeah, minus 1 by 2 integral theta is equal to 0 to pi by 2 e power minus infinity is 0 and e power 0 is 1 and again into d theta. So okay, now have to do the integration with respect to theta here. Yeah, okay, I am doing here integration with respect to theta. Then minus 1 by 2 integral theta is equal to pi by 2, and this minus as a plus here, and 1 d theta. Then 1 by 2, 1 d theta integration is theta, then 0 to pi by 2, then 1 by 2 into pi by 2, then final answer is pi by 4. Now I am going to explain about triple integrals here. So suppose f of x comma y comma z be a function defined over three-dimensional finite region V here. So x comma y comma z, that means three variables are there here, three variables. So if z1 z2 are the functions of x comma y and y1 y2 are the functions of x and x1 x2 are constants, then the triple integration is here. At first doing integration with respect to z, because z limits are as a functions of x comma y, okay, and then doing integration with respect to y, because y limits are as a functions of x here, and last we are doing integration with respect to x here, that means x limits are constants only, okay. So if z limits are as a functions of x comma y, doing first integration with respect to z, and if y limits are as a functions of x, doing second time integration with respect to y, and finally the constants values integration, okay. The triple integral means writing three times integration with respect to z and with respect to y and with respect to x here. So one problem is there here. Evaluate integral minus 1 to 1, integral 0 to z, integral x minus z to x plus z, x plus y plus z, dx, dy, dz was given here. So we have to evaluate this problem. Then at first I am writing the given question. Integral minus 1 to 1 and 0 to z, x minus z to x plus z, x plus y plus z, and dx, dy, dz. So at first observe limits here, students. See here, x, z in as a functions of x, z was given here, first integration limits, and second integration limits as a function of z was given here, and third integration limits as a constants was given here. See here. So the first integration limits as a x comma z was given here. Then third triple integration consisting three variables. On that three variables, two variables are here, x comma z. Then these x comma z limits are corresponding to the variable y only. Okay, and next limits. Z limits were given here. So already z limits are there here in y as a function of x comma z here. Then here the second integration was given as 0 to z. That means 0 to z means this is variable limit. Then these limits are x limits. Okay. And the last limits are as constants. This was given in the question. Okay, the first limits are y limits, and the next limits are z limits and x limits, and next limits are here z limits. Okay, or otherwise you may choose here, and these limits are y limits this one, and these limits are x limits only, so no chance to choose in another way. Then here I am writing the limits. So y is equal to x minus z to 2 and x plus z, and x is equal to 0 to z, and z is equal to minus 1 to 1. Then integrand function x plus y plus z. Then at first integration is with respect to y, and then integration is with respect to x, and last integration is with respect to z here. Okay, so now doing the integration. At first integration is with respect to y here, students. At first integration is with respect to y. So integral z is equal to -1 to 1, integral x is equal to 0 to z. So now doing the integration with respect to y, the integral is xy plus y integration is y square by 2, and z integration is zy between the limits x minus z to x plus z. With respect to y is completed here, and next integration is dx dz. Okay, so I am writing here how you will get xy and zy here. See here, integral x plus y plus z with respect to y is here, dividing integration x dy and y dy and plus integral z dy. Okay, so x is constant, then 1 dy, because we are doing with respect to y integration, x is constant, and y integration y square by 2, z is constant and 1 dy. So finally the integration is xy plus y square by 2 plus zy. So I wrote here this value xy plus y square by 2 and plus zy here. So now the substituting the limits here, integral z is equal to -1 to 1 and integral x is equal to 0 to z. So in the place of y you have to substitute the limit, students. So x into upper limit and minus lower limit, and okay, and plus 1 by 2 common, and y square is there. So upper limit minus lower limit, and again plus z into upper limit minus lower limit, and again we are having the integral terms dx dz as it is. And see here, students, how you will get this value. I am writing here xy is there here, the first term, between the limits x minus z to x plus z. Then first one is upper limit x plus z and minus lower limit. Okay, then x into x plus z multiplied with minus here, minus x plus z. Okay, that one only I wrote here, x plus z minus x plus z. Similarly for the last term also. So now I am doing the simplification of this one. Integral z is equal to -1 to 1, integral x is equal to 0 to z, and minus x plus 6 will be cancelled, x into 2x and plus 1 by 2, and total this term x plus z whole square minus x minus z whole square is 4xz, and plus z into here also plus x minus x will be cancelled, and here not y, z here. Then z plus z is nothing but 2z and dx dy. Okay, so how you will get 4xz here? So here if a plus b whole square and minus a minus b whole square is equal to 4ab, or you may expand this x plus z whole square and x minus z whole square values using these two formulas, then you will get the value as a 4xz. See here, x square plus y z square plus 2xz, and next thing is x square plus z square minus 2xz, and between minus is there, then symbols will be changes, then first two values will be cancelled, and final answer is 4xz only. Okay, so now doing the simplification of this term here. Simplification, first thing x into 2z as 2xz, integral z is equal to -1 to 1, x is equal to 0 to z 2xz, and doing the cancellation, and again plus 2xz and plus 2z square dx dz. So I have to do the second term integration with respect to x here. Z is equal to minus 1 to 1. So I am doing with respect to x here. Then 2z constant. X integration is x square by 2. And here also 2z, x integration is x square by 2. And plus here 2z square constant. And one integration is x. Then 0 to z limits. And here also 0 to z. And here also 0 to z. And again dz. Then integral z is equal to minus 1 to 1. And this 2 will be cancelled and this 2 will be cancelled. Z into z square and again plus z into z square plus 2z square into z. Okay, I substitute only upper limit because the lower limit value is 0 here. Then integral z is equal to minus 1 to 1 and z cubed plus z cubed plus 2z cubed dz. Okay, so now adding these three values, z cubed plus 2z cubed is nothing but here 4z cubed here. Okay, and 4z cubed integral z is equal to minus 1 to 1 4z cubed dz. So now 4 is common. And z cubed integration is z power 4 by 4 within the limits minus 1 to 1. Then 4 will be cancelled and z power 4 minus 1 to 1. Then upper limit minus lower limit. Okay, 1 minus, so minus 1 power 4 is nothing but 1. Then final answer is 0. Coming to the one more problem here. Evaluate triple integral of x plus y plus z dx dy dz taken over the volume bounded by the planes x is equal to 0, x is equal to 1 and y is equal to 0, y is equal to 1 and z is equal to 0, z is equal to 1. Okay students, so now finding this triple integration taken over the volume bounded by the planes was given here. Okay, the solution. Given planes are x is equal to 0, x is equal to 1, y is equal to 0, y is equal to 1, z is equal to 0, z is equal to 1. So now the evaluate integrand term x plus y plus z and dx dy dz. So using this plane equations only we are taking the limits here. Z is equal to 0 to 1, y is equal to 0 to 1, z is equal to 0 to 1, x plus y plus z dz dy dx, because you wrote in the order here first z and next y and next integration limits as x here. See here students, three variable limits are in terms of constants only, so there is no restricted here. We may do the integration at first for z or y or x because the three variable limits are constants only. So at first I am doing with respect to z here integration. Okay, integral x is equal to 0 to 1, integral y is equal to 0 to 1 xz and yz plus z square by 2. So in the previous problem I explained about how you will get here xz here, because x is treated as a constant and 1 will be there, for one integration is z only here. So xz plus yz plus z square by 2 within the intervals 0 to 1 and dy and again dx. Okay, now substituting the limits of z at first. Okay, substituting the limits of z. Integral x is equal to 0 to 1, integral y is equal to 0 to 1. For z only substitution, y into 1 and plus 1 by 2, and next integration is dy dx. Okay. So next I am doing integration with respect to y here. So x is constant. For one integration with respect to y is y, and for y integration is y square by 2, and for 1 by 2 one integration is y within the limits 0 to 1 and into dx. Okay. Okay, now substituting y limits here, only y limits, I am doing the substitution. Integral x is equal to 0 to 1, x into 1 plus 1 by 2 and again plus 1 by 2 dx. Yeah, integral x is equal to 0 to 1, x plus 1 dx, because 1 by 2 plus 1 by 2 is nothing but 1 only. So now with respect to x integration, x square by 2, and for 1 integration is x 0 to 1, substituting upper limit 1 by 2 plus 1, because lower limit is 0, that's why I am not substituting here. 1 by 2 plus 1 is nothing but 3 by 2 is the final answer of this question, taken over the volume bounded by the planes. The next problem, evaluate integral 0 to 1, integral 0 to 1 and integral 0 to 1 e power x plus y plus z dx dy dz. Okay, so here the three variable limits are constants only. Then we may do the integration as with respect to z at first, or y or x here. Okay, so x is equal to 1, I am choosing as x is equal to 1, y 0 to 1, y is equal to 0 to 1, z is equal to 0 to 1, and I am writing the integrand term as e power x plus y into e power z. So and first integration is with respect to z, and then dy and then dx. Okay, integral x is equal to 0 to 1 and integral y is equal to 0 to 1. So at first doing integration with respect to z, then e power x plus y is as it is, then e power z integration is e power z only within the limits 0 to 1, then next integration values dy dx. Then integral x is equal to 0 to 1, integral y is equal to 0 to 1, e power x plus y. So e power 1 minus e power 0, upper limit minus lower limit. Okay, and integral x is equal to 0 to 1, integral y is equal to 0 to 1, e power x plus y, e minus e power 0 is 1, then dy dx. Okay students, so now the integration with respect to y, the next integration is with respect to y here. So before that, e minus 1 is a constant here, e minus 1 as common, e minus 1, and integral x is equal to 0 to 1, then e power x into e power y, I am writing this term, y is equal to 0 to 1, and dy, the next integration is dy. Yeah, okay, and e minus 1 into integral x is equal to 0 to 1, e power x is constant, e power y integration is e power y, 0 to 1 limits, and again next is dx. Then integral x is equal to 0 to 1, e power x, e power 1 minus e power 0, and again dx. Then again doing the substitutions, After substitutions, e minus e power 0 is 1. Then again making e minus 1 as a common here. The last integration is with respect to x here. Okay. Then e minus 1 and e minus 1 as e minus 1 whole square. Integral x is equal to 0 to 1 e power x dx. Yeah, e minus 1 whole square. Again e power x integration is e power x 0 to 1 dx. Then e minus 1 whole square e power 1 minus e power 0. Then e minus 1 whole square, again e minus 1. Then final answer is e minus 1 whole cube. And thank you students. Please like, share, subscribe Easy BTech channel.